Today's notes are going to be on 3.5, the scatter plots and lines of best fit. So we need to understand the association. For example, 1, what is the relation between the hours after sunrise, X, and the temperatures, Y, shown on the scatter plot? Well, if we're looking at this, if you notice, the temperature is generally increasing over time. So it's actually going up. So the hours of sun after sunrise, so the later it gets, the higher the temperature is. So as the number of hours after sunrise increases, so does the temperature. When Y values tend to increase, the X values also increase. That's why it's going up. The two data sets have a positive correlation. So here, this is called a positive correlation if it's going up. Now in example 1B, if we notice, what is the relation between the hours after sunset? So basically now the sun's going to start going down, and the temperature. If you notice, look, it's going down. Okay, this is called a negative association. Remember, when you're reading a graph, you always read it left to right. So as the number of hours after sunset increase, the temperature decreases. So when the Y value tends to decrease as X values increase, the two data sets have a negative association. In example 1C here, what is the relation between the hours after sunset, X, and the amount of rain, Y? If you notice, I can't connect my dots or not even draw a line through here. It's like high, high, low, low, high. So this is called no association right here. There is no relation between the amount of rainfall and the amount of hours after sunset. When there is no general relation between X and Y, that is called no association. So we look at the next ones right here. Let's see. If I'm looking at this one, if I'm going left to right, you can draw a line in between here. So this one is going to be called a positive association. So this one right here is a positive association. Right here, it's kind of all over the place. So because it's all over the place, this one is going to be no association. And on the last one, if you notice, the dots are going down almost linear. So this is going to be a negative association. Next one. So understanding the correlation here. So for example, we have, how can the relation between the hours after sunrise, X, and the temperature, Y, be modeled? The data points on the scatter plot approximate a line. We're going to sketch a trend line that best fits the data to determine whether a linear function can be modeled, the relation. So right here, what we're going to do is we're going to draw a best fit line. The goal is to try to get as many dots above it, below it, and on it to try to make it equal. So right here, the scatter plot suggests a linear relation that is positive. It's positive because it's going up, correlation between hours after sunrise and the temperature. When the data with a negative association are modeled with the line, that is a negative correlation. So if the dots were going down, that'd be a negative. If the data did not have any association, they cannot be modeled with a linear function. So on the no correlation, we're not going to draw a line. So right here, it says, how can the relation between the hours after sunset, X, and the temperature, Y, be modeled? If the relation is modeled with a linear function, describe the correlation between the two data sets. So right here, I can draw a line between down here. If you really wanted to, you can draw a relationship down here. This is going to be a negative correlation. The relationship can be modeled by a trend line. If I wanted to, I could draw the line. the hours after sunset and the temperature would have a negative correlation. I'm going to go ahead and flip the page there. So right here it says write the equation of a trend line. What trend line models the data in the scatter plot? A trend line models the data in a scatter plot by showing the general direction of the data. A trend line fits the data as closely as possible. Step one, we're going to sketch the trend line for the data. So a trend line approximately a balance of points above and below the line. That's what I said earlier. So we're going to, like right here on the trend line, we have 3 above, 3 below. We have like these ones, that point line going through the 3. So right here, trend line might not pass through any of the points. So sometimes it doesn't pass it. Like right here, it slightly touches it. But we have a good amount that's above and below. So now we're going to write the equation of the trend line. So we need to select 2 points. So right here, we just select those 2 points. And then we are going to do the y equals mx plus b form or slope intercept form. So right here it says select 2 points, which we did, 250 and 16,500. So when we have those 2 points, so we have 250 and 16,500. To find the m value, remember the m is equal to y2 minus y1 over x2 minus x1. This is x, this is y, this is x, this is y. I'm going to label this as 0.1 and this is 0.2. That's where we get the 500 minus 50 and the 16 minus 2. So that's going to be 32.1. Next, we're going to go ahead and we're going to use a slope intercept form. Y minus y1 equals mx minus x1. And then the trend line models that the data is right here. If we go ahead and we distribute, so right here, if I have y minus 50 equals 32.1 times x minus 2, if I distribute this right here, this is y minus 50 equals 32.1x minus, now let me see what 32.1 times negative 2, that gives me a negative 64.2. And if I add 50 to both sides, y is equal to 32.1x minus 14.2. And that is the trend line here. Right here, we're going to go ahead and we're going to draw a trend line. So let's try our best that we can. Let's see here. Ooh, I probably should have drawn it a little bit this way. Okay, let's see if that works though. Okay, so let me redraw that. Yeah, because that's what kind of way off. Let's go more this way. Yeah, that's a little bit better. So right here, look, x is 2, y is about 68. And then our next point, we'll pick like right here. So that is a 7 and a 62. So here we have the point 268 and 762. Anything's going to be very close to it though. So right here we have an x and a y, an x and a y. This is 0.1, this is 0.2. So I'm going to go ahead and calculate my slope. Remember, the slope is going to be y2 minus y1 over x2 minus x1. y2 is a 62, y1 is a 68. x2 is a 7, x1 is a 2. That's going to be a -6 over -5. A negative makes that a positive. So this is actually 6 over 5. Or if you actually divide that, that's 1.2. Now I'm going to use my slope-intercept form. Y minus y1 equals m. X minus x1. I mean point slope form. Sorry, point slope form. This is your m value. And then I'm going to go ahead and I'll use this x and this y. So I have a y minus 68 equals m, which is 1.2 x minus 2. I'm going to go ahead and distribute here. So this is y minus 68 equals 1.2 x minus 2.4. And then I'm going to add 68 to both sides. So I get y equals 1.2x plus, that's actually going to be a 70.4. And actually, this was a negative. Because 7 minus 5 is positive 2. I'm sorry, I just caught that right now. Sorry about that. All right, interpreting trend lines. So the data shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? So right here, we're going to pick those 2 points. So we have the point 46 and 55.4. This is x, this is y, this is x, this is y. This is going to be 0.1, this is going to be 0.2. I need to find my equation. So first, let's go ahead and find our m. Our m is going to be the y2, which is 4, minus y1, which is a 6, x2, which is a 55, minus x1, which is a 40. That's going to be a -2 over a 15, which is negative, let's see, 2 divided by 15. That's going to be -1.3. Or 0.13, sorry, 0.13. And that's approximately because we were rounding. So when we write the equation, once again, we have y minus y1 equals m x minus x1. I'm going to go ahead and I'll just use this one as my x1 and my y1. And then this is going to be your m right here. So we have y minus 6 equals -0.13 x minus 40. I'm going to go ahead and distribute. So this is y minus 6 equals -0.13x plus 0.13 times 40. That equals 52 or 5.2. Don't remember, forget the decimal. And then when I add 6, I have y equals -0.13x plus 11.2. So now we're going to use our equation and find out what when x equals 75. So I'm going to plug in a 75 right there. So I have a -0.13. X is 75 plus 11.2. So I have -0.13 times 75 plus 11.2. And that answer comes out to be 1.45. Now keep in mind, the X is the internet speed. So what this represents is the download time. The download time would be 1.45 seconds. Now we're going to go ahead and do some understanding here. So it says, how can you use a scatter plot to describe the relation between 2 data sets? A scatter plot can show a positive association, a negative association, or no association. A student claims that if the y values are not increasing as the x values increase, then the data must have a negative association. No, that's not true. It does not have to be a negative association. It could have no association. In a scatter plot that shows a positive association, describe how the y values change as the x values increase. As the x values increase, so does the y. As the x values increase, the y values also increase. Does a trend line need to pass through all the points? No. A trend line will not pass through all the points in a scatter plot. It will usually only pass through a couple. However, it is possible that it will not pass through any. Describe the type of association between the x and the y. If you guys notice, the points are going up. So this is going to be a positive correlation or association, sorry. Different books that use different words. This book uses association. This is a positive association. As the x values increase, the y values increase. As x values increase, y values increase. On this next one, you're given a table. If you want, you can plot the points, or we could just look at the numbers. Look at the numbers. This is going 4, 6, 7, 9, 10. This is going up, if you notice. So as the x is going up, let's look at the y values. It goes 9, 7, 5, 3, 3. The y values are going down. So as the x values are going up, the y values are going down. So what is that causing? That's causing a negative association. So this is a negative association. As x values increase, y values decrease. Now the table below shows the hours of studying x and the person's test scores y. So right here, and then it says write in what is the equation of the trend line that models the data. So once again, we need to find our equation. We need to pick 2 points. It doesn't matter which 2 points you pick. I'll go ahead and I'll use this one. So I'll use the 677 and I'll use the 887. I'm going to try to stay away from this one only because there's 2 7s. So here's x, y, 0.1, 0.2. So my slope is going to be y2, which is 87, minus y1, which is 77, over x2, which is an 8, minus x1, which is a 6. So that's 10 divided by 2, which equals 5. I'm going to use this point right here as my x1 and y1. So when I write my equation, that's y minus y1 equals m x minus x1, y minus 77 equals 5x minus 30. I'm going to go ahead and add 77 to both sides. So y is equal to 5x plus 47. Now, your answer may vary depending on which 2 points. However, your your m value should be a positive and the b value should also be a positive. So right here, the slope is the point increase per hour of studying. So the longer you study, the higher your score will be. The y-intercept is for somebody who didn't study. The y-intercept is for someone who didn't study. And that concludes our notes.